A massive hidden planet may be moving somewhere beyond Neptune right now. Scientists still haven't seen it directly, but multiple studies suggest something enormous is affecting the outer solar system through gravity alone. And immediately, one ancient name started spreading online again: Nibiru. According to one of the most controversial theories on the internet, Nibiru is a hidden planet connected to the mysterious Anunnaki, powerful beings described in ancient Sumerian texts thousands of years ago. Some people believe this object periodically enters the inner solar system, and that ancient civilizations may have known about it long before modern astronomy existed. Normally, theories like this would be ignored completely. But the problem is that astronomers really are searching for an undiscovered planet right now. The story starts far beyond Pluto, in the outer edges of the solar system. Over the last several years, scientists noticed something strange about the orbits of distant icy objects beyond Neptune. Instead of moving randomly, several objects appeared clustered together in ways that suggested the gravity of a much larger unseen body might be affecting them. This eventually led researchers to propose the existence of a possible hidden world known as Planet 9. Some estimates suggest this object, if it exists, could be between 5 and 10 times more massive than Earth and orbit hundreds of times farther from the Sun than our planet does. At that distance, it would reflect almost no sunlight, making direct detection extremely difficult even for modern telescopes. And that is exactly why the Nibiru theory exploded again online. Because according to older alternative theories, ancient civilizations already knew about a hidden planet long before scientists started discussing Planet 9. The civilization most often connected to this mystery is the Sumerians. More than 5,000 years ago, the Sumerians built one of the earliest advanced civilizations in human history in Mesopotamia. They developed writing, mathematics, astronomy, large cities, and detailed mythological systems. Within many of their ancient stories appear references to powerful beings called the Anunnaki. Mainstream historians interpret the Anunnaki as mythological deities connected to creation stories, kingship, and religion. But alternative interpretations claim these beings came from the sky and were associated with a wandering planet called Nibiru. According to the theory, the Anunnaki periodically traveled between Earth and this hidden world. The idea became especially popular because of certain ancient carvings and symbols. Some Sumerian artwork appears to show celestial patterns, unusual objects, and star imagery that internet theories often describe as evidence of advanced astronomical knowledge. One of the most famous examples involves the so-called Sumerian bags, strange handheld objects carved into stone reliefs thousands of years ago. Similar shapes also appear in unrelated ancient cultures, which only made the mystery grow online. Supporters of the Nibiru theory claim these symbols represent lost knowledge connected to the Anunnaki. The most extreme versions of the story go even further. Some claim the Anunnaki genetically altered early humans, helped build early civilizations, or left encoded astronomical information hidden inside myths and ancient texts. There is no scientific evidence supporting those claims. But what makes the theory difficult to completely dismiss online is the strange overlap between ancient mythology and modern astronomy. Because scientists really are searching for a large unseen object in the outer solar system. And every time new research about Planet 9 appears, the internet immediately reconnects it to Nibiru. At the same time, astronomers continue finding unusual objects beyond Neptune. Some dwarf planets and icy bodies follow orbits that still do not have perfect explanations. Researchers believe a hidden planet remains one possible answer. Powerful observatories are currently scanning deep space, searching for faint movement patterns that could finally reveal whether Planet 9 exists. So far, nothing matching the dramatic descriptions of Nibiru has ever been confirmed. No giant rogue planet is heading toward Earth. No evidence of extraterrestrial visitors has been discovered in ancient Mesopotamia. But the theory refuses to disappear for one reason. An ancient civilization described powerful beings descending from the heavens. Modern astronomers believe another massive world may still be hidden somewhere in the darkness beyond Neptune. And for millions of people online, those two stories became connected in a way that is now impossible to separate.
This catapult-like system on the Moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the Moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The Moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the Moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the Sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out.
You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space, and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star.
Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating, but the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely, but that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. is 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy. And this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy materials settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size. Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be 2 ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden.
Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the north pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system. But not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the The polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it. But it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon, Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis, and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of two parallel universes. Imagine that universes are giant bubbles, and one day, two of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe.